Hello everyone, this is Shahinur Rahman Laskar from Department of Computer Science and Engineering, National Institute of Technology, Silchar, Assam, India. I am going to present multimodal neural machine translation for English to Hindi. So these are the outlines which I am going to cover. First, I will briefly give the introduction, then the related works, then I will discuss about the data set, then our system description, then result and analysis, and then finally conclusion and future work. So machine translation mainly focus the automatic translation of text from one language to another language. Neural machine translation, that is one of the widely accepted and achieves a state-of-the-art approach in machine translation community that basically use the advanced deep learning techniques and which handles issues like long-term dependency and contextual analysis. But NMT still suffers translation problems for low resource language pair translation. To encounter this challenge, the multimodal based concept is introduced, where features like textual and visual features can be combined to improve the translation of low resource language pair. Moreover, the utilization of monolingual data in the pre-training step also can improve the performance of the system for such low resource language translation. Uh, Workshop on Asian Translation 2020, that is WAT 2020, organized a translation task for multimodal translation in English to Hindi, and we have participated in the same task for two track. One is text only, other one is multimodal, with our team name CNLP needs. Now coming to the related work, the existing survey finds out very limited works on English to Hindi language pair translations. In the paper 1, they used synthetic data following the multimodal NMT settings of paper number 4 and achieves blue score 24.2 for Hindi to English translations. Moreover, in WAT 2019 multimodal translation task of English to Hindi, paper number 3, based on recurrent neural network, achieves blue score 12.58 and 28.45 for the challenge and evaluation test set. On the same task, WAT 2019, we have also participated and we have achieved the highest blue score 20.37, 40.55 for the challenge and evaluation test set. We have used RNN encoder and doubly attentive RNN decoder based model following the architecture of following the settings of paper number 1. The loophole in the existing works of English to Hindi translation using multimodal NMT is that they have not used the monolingual data to improve the performance of multimodal NMT. In this paper, we have used monolingual corpus in the pre-training step to enhance the performance of the multimodal NMT for English to Hindi translation. So this is the dataset descriptions. First, figure 1 parallel data that is supplied by the organizer. Here the text data and as well as image data is available, and then we have used external monolingual data from WMT16 for English monolingual and Hindi for IIT Bombay. For system description, we have used OpenNMT Pi tool to set up our multimodal NMT as well as text-only NMT system. The system operation includes 3 things. One is pre-processing, then training to generate the best model, and then the obtained model is used for translation purpose to predict the translation on the given test data. So first, data processing. So here for multimodal translation, we have used pre-trained CNN with BGG19 for the extraction of global and local features from the provided image dataset. And in the text only and multimodal task, we have used globe to pre-train monolingual data of English Hindi and generated global vectors of word embedding. The OpenNMT PyTool is used to create vocabulary library size of 5004 for both source and target sentences. The training data, in the training phase, we have utilized in multimodal translation that pre-trained vectors, extracted visual features from data processing in the fine-tune with parallel text data, and we have used bidirectional RNN to at encoder type and doubly attentive RNN at decoder type following default settings of RNN settings of paper number 1. PRNN uses two distinct RNN, one for the forward direction and another for the backward direction, and two different attention mechanisms are incorporated across the source and visual features at a single RNN decoder. Two-layer LSTM having 500 nodes in each layer, both encoder and decoder. Our model run up to 40 epochs with 0.3 epoch basis per. And then in testing phase we have utilized our trained model on the test data. So this is the results. So we have this result is declared by the organizer, and we have achieved higher blue score in case of multimodal NMT for evaluation metrics blue, RIPS, MFM. So this is the best performance example. The source contains a bunch of books on the book stem. So our predictor sentence is close to references as well as Google translation. And this is the example of vast performance of our model. So now coming to the conclusion and future work. Here we have participated in 2020 multimodal task of English to Hindi, and in the future work we will do more experiment analysis to improve the performance, and we will modify the existing architecture in order to improve the translation accuracy. Then we would like to thank Center for Natural Language Processing and Department of Computer Science and Engineering at National Institute of Technology Silchar for providing support and execute this work. Also, we would like to thank WARC 2020 Translation Task Organizers. This is the references. Thank you.